In this video, we're going to try and integrate cos to the power of n. So we are going to try and integrate this, but visualize this as being one block multiplying with another block here. So combining these two will give us cos to the power of n of x. Okay, so visualize it as one block multiplying another block, and then let's this block here be u, and then let's this block here be v prime. Well, if u equals this, if u equals this thing here, then u prime equals this thing here. So basically, you're just differentiating this. Okay, if you differentiate this, it will give you this whole thing here. And then if v prime equals this thing here, so v prime equals this thing here, then normal v would be sine of x. So now following this this formula here, so u times v. So where's u? U is here times v. So that would be cos n minus 1 of x, and then times v. So that will be sine of x, and then you've got your minus here, minus the integral of u prime. Well, u prime is this thing here. Okay, and you've got a minus here, so it would be minus, and then don't forget u prime times v. So it's going to be this whole thing here times this thing here. So you've got a minus here, so that there's going to be a minus here, and you've got a sine here and a sine here. So that would be sine squared of x, and then you've got this thing here. So that would be well, put everything into there, and then you've got your dx here, then it will give you this, okay, it will then give you this thing, and then plus this thing here. Okay, so this is our sine squared here, and then this was what's left over, and don't forget this here is a constant. n minus 1 is a constant, so you can actually take the n minus 1 out. Okay, so hang on. So if you substitute, looking at this bit here, this whole thing here will become this, will become this. Okay, don't forget earlier this was in here, so because n minus 1 is a constant, you can take it out. Okay, so overall it will be this whole thing here. So now looking at this, hang on, looking at this, so here you've got one block multiplying with another block here. Remember that one equals sine squared plus cos squared. So we can put 1 minus cos squared of x into this thing here. Okay, so that would then take us to here. So that would then give us this thing here. Okay, 1 minus cos squared of x. So we are currently here, and now, hang on, and now let me think. Sorry, hang on, let me think. So we are currently here. Oh yeah, so now so we are currently here. So now visualize this as being this here is one block, and then here you've got brackets here. So get this times this, and then this times this. So that will then take us to here. Okay, that will then take us to here. So now you've got one thing minus another thing, all within brackets. So you can say that this here is one integral, and then this here is another integral. Okay, so that will then take us to here. Okay, so hang on, so here you've got one integral, and then you've got another integral here, but then don't forget you've got this constant here. So now you've got to do this times this, and then this times this. So that will then give you this. So this is your n minus 1 here. So this is one block, and then you've got your n minus 1 with another block here. So it would then, if you think about it, from here it will take you to here. Okay, so let me just repeat this one step here. So so if you look at this, you've got brackets here. So you can think of it as being the integral here, and then you've got another integral here. And then don't forget all these are in brackets, and then now you've got this constant here. So now it's going to be this times this and this times this. So that will then take you to here. Okay, and then let me think. Hang on, and then from here, hang on, let me think. Oh yeah, so we are currently here. So now looking at this here, so hang on, you've got one block here, and then you've got another block here, plus this block here, and then minus this block here. That's what you've got at the moment. So we've got an equation here where on the left hand side we've got this, on the right hand side it would be this block, plus this block, take away this block. So we are currently here at the moment. So from here, now in your mind, add equally to both sides. Add this block equally to both sides. Okay, so currently you've got this equation here, but in your mind, add this block equally to both sides. That will then give you this. So here we've got one block plus this block equal. So on the left hand side we've got this. On the right hand side we've got this block plus this block. Okay, so let me go back one step. So we are currently here at the moment. So in your mind, add this equally to both sides. So meaning this will move over to this side here. Okay, so hang on, we are currently here. So in your mind, add this block equally to both sides. That will then take you to here. To here. Okay, so now let me think. So now you've got, looking at this here, you've got one block here, and then you've got times this block here. Well, now get this times this, and then this times this minus 1 here. So that will then give you this. So hang on, going back one step. So here you've got one block. Now get this times this. That will then give you n times that integral. So that will then give you this n times the integral. And then you've got to get this times the negative 1 here. That will then give you negative the same integral. Okay, so hang on. So from here, multiply this out. So this times this times this. That will then give you this. So the left hand side equals this, the right hand side equals this. Okay, so we are currently here at the moment. So we are currently here at the moment. So now looking at this, you've got one block. On the left hand side you've got one block, and then you've got this plus this block, take away this block, and then on the other side of the equation you've got this block plus this block here. Now if you look at this here, this is exactly the same as this, so they cancel each other out. These two will cancel each other out, just leaving you this on the left hand side. So just on the left hand side is this, and then on the right hand side is this. Okay, so you may have to think about this. So you are currently here at the moment. So these two will cancel out here. So that will then take us to here. So now remember, this was our primary aim here. Our primary aim was to find the integral of this. So now divide both sides by n here. So that will then give you this, and then that will then give you this. Okay. By right, well, divide both sides by n, but then you can move it out here. So you can actually do this. So anyway, from here, divide both sides by n. That will then give you this. So that will then give you this. And this, by the way, is what's called a reduction formula. So you've got something that's complicated, and then now it becomes slightly easier, but you still have to work out the integral of this. But the good thing is that the good thing is that from n here, it has become slightly simpler, but you still got to work out this integral here. So this whole thing here is called a reduction formula. So to work out cos to the power of n, it will then give you this. But the thing is, you still have to evaluate this. But the good thing is that it becomes slightly simpler. So then you would repeat the process on this part here. Okay. So for example, if you want to integrate this, it will become this. So let me give you an example. So an example is that cos to the power of 3 of x. So if you want to integrate this, if you follow the formula, if you follow this formula here, if you follow this reduction formula, this thing here will become this. Okay, because don't forget n here is n here, and then here you've got n to the minus 1. In our case, it would be 2. So well, if you think about it, follow the formula, it will then give you this. Okay, so now you still got to evaluate this. So evaluating this would give you this. So overall, for this example, when it's cos to the power of 3, it will give you this. Okay.